In this video, we're going to be solving a rational inequality. When solving a rational inequality, you want to begin by writing the inequality in general form, with the rational expression on one side and the zero on the other. So we'll begin by subtracting 3 from both sides, which will give us a 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And we're going to need common denominators because really we have a negative 3 over 1 there. So we'll need to multiply both the denominator and the numerator by the other denominator so we can get common denominators. That will give us a 2x minus 7 over x minus 5 minus 3 times x minus 5 over x minus 5. From here, we'll distribute our 3, which will give us a 2x minus 7 over x minus 5 minus 3x minus 15 over x minus 5. So at this point we can combine these, but it's actually a little bit easier while we still have them kind of separated if we distribute this negative sign right here to both of our numerator pieces, which would leave us with a 2x minus 7 over x minus 5 plus a negative 3x plus 15 over x minus 5. And then from here it's a lot easier to combine our like terms. I'm kind of out of space. We're going to come up over here. So when we combine our like terms, we're going to put our 2x with our negative 3x, which gives us a negative x. Then we're going to put our negative 7 with our positive 15, which is going to give us a positive 8 all over x minus 5. And then remember, that was less than or equal to 0. From here, in order to find our key numbers, we're going to go ahead and take our negative x plus 8 and set it equal to 0. And we're going to take our x minus 5 and set that equal to 0 in order to get our key numbers, right? So our key numbers here are going to be x equals a positive 8 when we solve the first one, and x equals a positive 5 when we solve our second one. So that's going to give us the intervals from negative infinity to 5, then from 5 to 8, and then from 8 to positive infinity. And our x values, let's pick x equals 0, x equals 6, and x equals 10. Those seem like some good numbers to pick. Or even, let's pick something that's not like with a 0. So let's pick something 9, a little bit tougher, give us a challenge. And now we're going to look for our polynomial value. So remember, this is where we take our x values and we plug them into our rational value, our rational expression there. We plug it in to get our answers. So when we plug in 0, we're going to get a value of negative 8/5. When we plug in 6, that gives us a value of 2. And when we plug in the number 9, that gives us a value of negative 1/4. And so now we can look at our signs. Here we're going to have a negative portion here and here, because those are negative numbers. And then at 2, we're going to have a positive. And because our inequality was a less than or equal to 0, we're looking for our negative intervals. And so we can write down the intervals negative infinity to 5, unioned with the interval from 8 to infinity. Now I want to point something out really quick that's kind of important. Because we have a rational expression here, it's important to note that x is not allowed to be the number 5 because we'll have a 0 in the denominator. And that's how come we have an open portion of our interval here. However, x does in fact equal 8. And so really, we shouldn't have an open interval at this point. We should have a closed interval, like a closed at 8 interval, which then goes to infinity. And so this is how our solution should be written. So it's important to make sure you double check what x is in fact allowed to be and what x is not allowed to be. And again, I was allowed to say that because when we plug in the 8, that gives us the equal to portion of our less than or equal to. And so that's why we're able to close that interval at the 8.